As always, your eyes are your best tools. Uh, Really, it's amazing what you can diagnose just by sight or feel. As a matter of fact, look around in the picture. Tell me if you can find the toaster. Anyways, safety first. Never open a radiator cap on a hot engine. It can flash boil, and we'll talk more about this in a minute, but just realize, we need to check and make sure before we open up the cooling system that it's not pressurized and not hot. Uh, and this the antifreeze is poisonous. Some less so, but just treat all antifreeze like it's poisonous. Read the label on the bottle first before any first aid is administered. Yeah, really try not to lick it. Uh, and it's also very slippery on a shop floor. Clean up after yourselves. It can get quite slick on an epoxy coated floor. Rear wheel drive cooling systems. They generally have a mechanical fan. I'll be talking about how to test those. We have radiator hoses, we have radiators, we have a water pump, we have a thermostat that opens and closes, and we have a heater core as well. This heater core is inside the vehicle. That's what gives you the heat on a cold winter morning, much like it is today. Snow and cold, nice. It's April. Front wheel drive. Front wheel drive stuff is much more compact. We have, basically the same parts, but instead of having a mechanical engine-driven fan, generally we have an electric fan. We have overflow recovery tanks and we have surge tanks. I'll talk about the differences. So what is coolant? Well, ethylene glycol is probably the most common, and then we have the polypropylene glycol as well. But by far the largest ingredient in it is water. Now, water freezes at 0 degrees, and that is a problem in the colder climates like it is here. Almost all manufacturers recommend a 50-50 mixture. Down south in Florida and stuff where it doesn't get as cold, they tend to use just straight water, which is a mistake. I mean, there's also, other stuff in there, other ingredients in there. Now, we can go to an extreme 60-40 mix is allowed, and that gets us much lower freeze temperatures of the antifreeze, which is what we're trying to, get away from. We hear a lot of manufacturers talk about permanent antifreeze and it doesn't need to be changed. Well, honestly, yes, it does. We get some combustion chambers into the coolant. Nothing is perfectly sealed. And that in turn creates, it gets acidic over time. The pH changes. And we end up having an issue with corrosion inside the cooling systems. And coolant does wear out. I mean, it's not the freeze property that wears out, but it's, the rust inhibitors and water pump lubricants. There's really only one moving part inside there, and that's the water pump. So thermostats, what do? Well, they open and close, and it allows, when it's closed, it allows the heat from the engine to build a lot more rapidly than if we, circulated it through the radiator. And that gives us, better drivability and lower emissions. A hotter engine is a more efficient engine. And that provides us with better fuel economy. And, a side benefit, it keeps us warm, which that's a good thing. I mean, back a long time ago, they didn't have heaters. It was just cold. That's where they developed car blankets. Anyways, so how does it work? Well, once the engine starts to heat up, if we started cold, it just runs through this like a bypass. So it's just the water pump is circulating it inside the engine. And we do this so that we don't develop hot spots in the engine. We circulate the antifreeze around the engine, helps stabilize the temperature. We can't have one part of the engine getting hotter than the other part, because then, differing rates of expansion would cause it to like blow seals and stuff. So this warm-up phase, the thermostat is closed, but there's still flow inside the engine, mixing the antifreeze. And then once the thermostat opens at a given temperature, generally about 190 degrees, it opens and it pushes the antifreeze through the larger hose to the radiator, which, there's air moving across the fins, and that's what helps helps the antifreeze cool, is it dissipates the heat using the wind from the ram air effect or the fan, and then we look at a radiator itself, and it has these corrugated fins in between these tubes that carry the antifreeze. So these fins are just helping it have more surface area so it can dissipate more heat. Most radiators have an oil cooler inside. Now, this is an oil cooler for the transmission generally. It has an transmission oil cooler inside. These are prone to leaks, and Nissan's had some issues with this. Quite a few of them. We have the Dodge Dakota in the shop right now that this leaked, and it blew all kinds of antifreeze into the transmission, which is really bad. So we look inside the engine. We have our water pump assembly, and then we have our cylinders. Now, the compression, the combustion event inside the cylinder creates heat, which is carried away by the antifreeze. And the water pump circulates this and inside the engine to help pick up the heat. And then when it reaches the correct temperature, the thermostat opens and it flows through the radiator. And then, also there's a separate circuit that is for the heater core to allow the antifreeze to go into the heater core. Radiator cap and recovery bottle. We keep a pressure. We keep the cooling system under pressure, because if we keep it under pressure, it raises the boiling point. So for about every 1 pound of pressure inside the cooling system, we raise the boiling point 3 degrees Fahrenheit. So a 15-pound cap raises the boiling point by 45 degrees, which puts us at, almost 250 degrees. Typical engine, modern vehicle is running its normal running temperatures about 225, 230 in there. Some of the more modern vehicles are even running hotter than that. As long as we keep it in that window, the engine can withstand that. If it gets above that, we start to have issues with cracking and bad, blowing a head gasket and cracking a block or cracking a head. Usually that's due to overheating. Now, this is a closed system, so it does build up pressure, although there is a relief valve in there. Now, this pressure, raising this pressure and raising the boiling point does allow manufacturers to keep the radiator and the cooling system smaller than it needs to be, if it was just an unpressurized system, which we did have a long time ago. Now, this pressure is contained by the radiator cap itself. Radiator cap has 2 valves in it. One valve releases pressure when it gets too high, and then once the system cools, it contracts back down. The antifreeze contracts back down, and there's another valve, a vacuum valve, at the base of the cap that draws the coolant back in from this recovery tank. You get this? It holds pressure, and this is what the radiator cap is, what regulates the pressure. It's this spring right here that gets pushed up. Let's say it's a 15-pound cap. At about 15 psi, it lifts up ever so slightly and bleeds off antifreeze and pressure into the recovery tank. And then when it cools off, it's the reverse that happens, and it's a separate valve that opens. So that draws the antifreeze back in from the recovery tank. That's why we have full cold and full hot marks on the recovery tank. Because when it's hot, when it's hot, it's pushed some fluid out, so that level inside the recovery tank is going to rise, and then when it cools off, it's going to drag it back down. Now, where do you think this pressure comes from? I mean, do you think it comes, well, I'll just tell you, the pressure comes from the expansion and contraction of the coolant. The coolant gets hot, it expands. That expansion creates more pressure, which holds the boiling point down, or raises the boiling point on it. So think about what happens. I have a hot pressurized system that's at 230 degrees, maybe hotter than that, because once you shut a car off, cooling system temperatures actually go up higher because, it does. So I crack that radiator cap off of there, pressure immediately drops down to atmospheric pressure. Well, if that antifreeze is above the boiling point, guess what happens? It flash boils. Where does it do this? Well, right around the cylinder jacket. So we get this sudden flash boil of the antifreeze that's surrounding the hottest part of the cylinder, which is, around the cylinder. And then that expands, because steam expands. That's why we get, an explosion of coolant out of a hot engine when we take the cap off. It's not so much just the pressure that's in there, it's the sudden flash boil that happens. We okay with that? No. We're going to take a break and come back to phase 2.